Hello there, I'm Thomas Hatsios, German America pilot flying the Boeing 787-900 tonight flight. We're going to be overflying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 14 for an Lszh localizer landing. So now in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments, displays, and the functions of the Boeing 787-900 aircraft. I'm gonna start with the primary flight display that displays the airspeed indicator. The airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the barometric pressure of the outside atmosphere, and the vertical rate of climb descent of the aircraft in tens, hundreds, and thousands feet per minute. All the steepness of the trigonometric angles in decreasing and climb descent. We have also the artificial horizon with the altitude indicator, the pitch ladder decrease, and the bank angle decrease. We have also the Lszh localizer, the instrument landing system of the airport runways that transmits radio frequency that is received is transmitted from threshold antennas, and we have a unique radio frequency which units time we take off and we land. So it's received from the onboard antennas of the aircraft and can help us to align with the horizontal localizer and the vertical glide slope for approach and landing, the angle of approach. So we're gonna have the Lszh localizer displayed in the primary flight display. You can see the Lszh localizer, the crossbars. We have also the flight director crossbars for manual guidance of the aircraft, and now the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode on zero with the autopilot and the auto throttle. Later on vertical navigation mode. We have also the HSI, the horizontal situation indicator, that displays the flight plan we're gonna use for flying. So you're gonna see the horizontal flight plan with the purple line, and connect the waypoints one by one that we have to fly through. You can see also we have the navigation display that displays the horizontal and vertical profile of the aircraft as it flies. You can see the terrain and weather reflections from the weather radar. You can see the terrain with a red, green, and a yellow rubber color indication depending of the distance and the altitude of the terrain around you and also below you in the vertical display. As we fly above the terrain, you will see it displayed. You can see also we have the magnetic North Pole and the geographic North Pole and magnetic variation depending on where we are in the world. We have also the terrain map that displays the GPS position of the aircraft, and also we have the inertial coordinates, the longitude and the latitude. We have also the airports where they allocated our own airport. You can see the taxiways and the runways we can use for takeoff and for landing, the length of the runway and its heading. We have also other airports where they are located. We can change the range of the map and see more airports further away. You can see also we have the navigation aids, the work stations, ADFs and DPs. We have also the waypoints which are horizontal and vertical navigation fixes and altitude and airspeed constraints. The aircraft we're gonna have to fly through some waypoints during this flight. I'm gonna show you how to fly through these waypoints. We're gonna connect them with the purple line when we create the flight plan, so we can guide the aircraft in the vertical and the horizontal profile with the flight plan. When we connect the autopilot flight director system panel and the LNAV and the VNAV function, we follow the flight plan we have created from the flight management computer. So you will see how I'm gonna use this function of the Boeing 787 also in flight. In the end part of the video, you're gonna see a complete flight from takeoff, climb, cruises, and approach and landing. So stay with me until the end part of the video to see the complete full manual flight. I'm gonna show you first all the systems one by one. So in the navigation display also we have the display of other aircraft that fly around our own aircraft. You can see them using the transporter, the ASP and ADC transmitter receiver that transmits our frequency to other aircraft and the air traffic control and receives from other aircraft. It will display the other aircraft. It will calculate from its computer the other aircraft location, distance from our aircraft and bearing. Also how many hundreds and thousands of feet are above or below our aircraft. The altitude difference from our aircraft, also whether the climb or descent with respect to our aircraft. We can also calculate the velocity closing in between our aircraft and the other aircraft. It will give us a warning from the TICA system, the Traffic Collision Advisory System warning. If we have an incoming collision in the air, we'll make an avoidance maneuver. Also in the ground you can see the other aircraft and the taxiways and the runways. So we have the TCAS information we have also. So this is all the navigation information we need right now. I'm going to show you also other systems, the autopilot flight director system panel, the engines indications, the outside view of the aircraft. I'm gonna talk to you about how to use all the flight controls of the aircraft. I will show you the flight controls of the Boeing 787. So I have the side stick here to use for controlling the flight controls of the Boeing 787-900 aircraft. It's similar with the Airbus aircraft side stick, and I can control the yoke of the Boeing 787. All flight controls functions are identical, no difference at all. So you can see here we have the flight controls. You can see the yoke. I can move in the pitch axis to climb, descend the Boeing aircraft. I have the side stick of the Airbus aircraft to control for climb, descend, back and forth. It's no difference. So back and forth in the Boeing or the Embraer or the CRJ aircraft, you climb, descend like this. In the Airbus you have the side stick, climb, descend, back and forth also, make left and right turns. In the Boeing you use the control wheel. In the Airbus you have the side stick left and right, no difference at all, same principle. So we have also the rudder pedals are the same both in Airbus and in Boeing aircraft. Control left and right the yawing axis, the rudder of the aircraft, and also the nose wheel string and the toe brakes. So you can see the rudder pedals. I will show you the outside view. I'll show you also the horizontal trim stabilizer here. In here we have the alternate trim pitch trim switch. I have the pitch trim switch here. So in the Airbus aircraft you have also the side stick priority. You can take either side, left and right, the side stick priority, or have dual input of the side sticks movement. You have also the push to talk button here in the Airbus aircraft, and the autopilot disengage switch here. So you can see all the setup I have right now for flying the aircraft. So you can see my computer. You can see I have the mouse pad here also to control all the screens and the keyboard for the flight management computer. So I'll use the flight management computer here to input the flight plan. Also I can use the autopilot flight director system panel here, other switches, the overhead panel also. I can set the barometric pressure here for the altitude display, inches of mercury or hectopascals. So it will display in the primary flight display. You'll see the barometric altitude. The aircraft is located above the ground, above the sea level actually. So you can see in the primary flight display we have the airspeed here, the airspeed indicator, the airspeed selected from the autopilot flight director system panel, the radio altitude above the ground level, how many feet we are above the ground, the radio altitude, the inches of mercury, barometric pressure over here to the 9.92 inches of mercury. You can see also the barometric altitude here, this state. So it displays 1430 feet, and the altitude selected from the autopilot flight director system panel, the target altitude. So we can set here also, as I tell you, the inches of mercury or hectopascals. You can increase or decrease the altitude the aircraft is above the sea level. Right now it's 29.92 inches of mercury or 1013 hectopascals, like that. We have also the minimum radio. We have also the map plan menu, range over here, nautical miles, weather radar, traffic, train, system, CDU, info, checklist over here, communications, navigation display, ACAS, engine, cancel, accept, left and right. You can expand and decrease the map display over here in the screens. Also you can see you can use either side to display. So we have the autopilot panel. I will talk to you about now in a couple of minutes. First, for the displays here, You can see also the pitch ladder over here in degrees. We have 2.5, 5, 7.5 over here, 5, 7.5, 10, 12.5, 15, 13.5 to the degrees for pitch up or pitch down when we fly, the pitch altitude of the aircraft. Also the wings over here level, the side slip indicator. You have also the bank in degrees bank roll, so you can bank roll 5, 10, 20, 30, 45 degrees to the left and right side, like this, make turns. And also you have the vertical rate of climb center of the aircraft over here. You need to pay attention. It's like 500, 1000, 1500, 2000, 3000, 6000 feet. It displays climb or descent per minute. This needle, when we climb, this needle moves up, and when we descend it moves down. So this is what actually tells you whether you climb or descend. Also the altitude tape and the airspeed you have to see all the time. You can see also the stall speed below here with red and amber or yellow. You can see the radio altitude will be like 2500 feet maximum. ADF left and right, the navigation display over here. You can see the magnetic heading 322 degrees versus the geographic North Pole. You can see the Düsseldorf airport over here in Germany. Here is Lszh, Switzerland. So this is the distance from Düsseldorf to Switzerland, Lszh. You can see here is France. If we increase the range right now, here is 18 nautical miles. This is for setting up the map display, plan, menu or map, range, and you can see also other systems from here or the checklist, and you can see later. So we increase a little bit the range, you'll see more airports, the Germany here, the France, this side, and the Switzerland. You can see also the aircraft one is fine. If we look closer, you can see the mountains we have to fly above in flight over here, in front of us or around. The distance where the mountains are located, 20 nautical miles here, 40 nautical miles here, 0 to 20. This is 36 kilometers over here approximately, then 72 over here. You can see also the altitude we have selected above the sea level for flying. We look closer, we look more mountains in front of us, more terrain like this. So you can see we are located 1430 feet. The altitude setting here 10,000. Altitude for flying over here. So we set the altitude. I'm gonna show you here the airspeed selected here from the autopilot, the direction system panel. We have the airspeed in nautical miles or knots, indicated airspeed, yes, or Mach speed, VNAV, LNAV, flight level change, climb continuous, auto throttle, autopilot, disengage like this. You can see auto throttle left and right, arm and disarm, flight director over here. You can set the airspeed like this. We'll set later the heading and the bank roll, the vertical speed and the altitude selected with hold switches, vertical speed. Also autopilot, engage this switch, disengage, and also approach, word localizer, and approach for autoland. So you can see either side what it displays, both sides of the pilot flight director system panel, and the displays, the panels over here. One second over here. So you can see also the outside view over here of the aircraft. I will talk to you now about how to use all the flight controls. So I'm gonna show you now the flight controls of the aircraft of the Boeing 787. How I use also the side stick that I have the Airbus identical side stick. I'm gonna show you the views outside. I will talk to you about the Newton's physics, aeronautical aerospace engineering, and derive some principles we need to know for the air transport pilot license and the commercial pilot license, aerodynamics. So we're gonna use the Newton's physics and the Bernoulli theory of fluids. So I'm gonna show you the outside view and how to use. Here are the flight controls again of the aircraft. For climb, descent, make turns left and right like this. The side stick, the roll axis over here, and now the pizza axis, the rudder pedals. We have also the nose wheel steering, the tiller here for the nose wheel. So you'll see now the outside view. You can see the aircraft here, the aircraft wings. The surface area of the wings hold the weight of the aircraft when the aircraft flies. The weight is divided over the surface area of the wings. Also, the wings produce the lift force for lifting the aircraft up into the air that overcomes the weight of the aircraft. We have the thrust from the engines, the propulsion that overcomes the drag, the thrust systems. So you have the jet blast from the engines. You can see the engines here. We have the high pressure compressor and turbine in the back section of the turbofan turbojet engines that push the jet aircraft forward. We have the high pressure compressor in the front and the fan of the jet engines. So this creates the jet wake that moves the aircraft, the jet aircraft forward. So we have the thrust vectors from the engines to move the aircraft forward. We have also the exhaust cones over here in the back of the engine. We have also the low and high speed spool of the turbofan turbojet engines. You can see also here we have the fuel lines from the top, from the left wing and the right wing fuel tank over here, the center tank. So we have 30% of fuel in the left and the right wing tank and 10% in the center tank. We have the main aerodynamic chord position over here with the maximum aerodynamic lift occurs in the forward wings is 23% approximately of the Mach. Where also the center of pressure is moving back and forth in the top surface of the wing. Also where the stall will begin, the airflow becomes detached from the top surface of the wings all the way back. And now the wings stall, so we need to monitor here inside the aircraft all the time when we fly. The airspeed indicated, the airspeed table over here. You have the stall speed just below the airspeed here with a red number or yellow color. So we need to push forward the side stick in the Airbus or the yoke in the Boeing aircraft, and also apply more thrust to make the stall avoidance in the air like this. So you increase the airspeed and you decrease the angle of attack of the aircraft. So this is the angle of a stall is fixed, and also the airspeed increase and decrease for stalling the aircraft. We need to avoid the stall in the air all the time. So you can see here we have the main aerodynamic chord position is also with the center of gravity transverses here of the aircraft. So this axis is the center of gravity. It's the yawing axis actually for all aircraft. You make left and right turns for all airplanes, left and right turns in the air, using the rudder pedals to control the yawing axis of the aircraft. You can see the vertical rudder. And we use also the nose wheel steering. In the ground you can turn the nose wheels, the forward nose wheels for 76 degrees to the left and right side using the rudder pedals. Simultaneously you move the rudder over here. So moving the rudder pedals you move the nose wheel steering. You can control using the tiller in left and right side, this tiller, and you also control the rudder. So this is double function for the rudder pedals. You control the nose wheel, also the toe brakes. You can press the top surface of the rudder pedals. You control the toe brakes of the aircraft. So you make left and right turns over here. So the nose wheel controls the yawing axis in the ground for takeoff when we are for takeoff. for example 76 degrees left and right, from 0 knots up to 45 knots, like 70 kilometers an hour, 76 degrees either left and right side deflection of the nose wheel. Then as we increase the airspeed, the nose wheel above 45 knots, we have the rudder aerodynamically effective. So above 45 knots or 70 kilometers an hour, 73, 74, is the rudder aerodynamically effective. So the nose wheel decreases from 76 degrees left and right turns to like 7.6 degrees automatically from the computer. Then above 80 knots, above 144 kilometers an hour, you have only the rudder to control the aircraft in left and right turns. So the nose wheel is decreased, is locked to 0 position, 0 deflection above 80 knots or 144 kilometers an hour in takeoff. So this is also controlled by the computer automatically. In the landing process is done the inverse process, so it comes back to function below 80 knots when you land, because we take off and we land like airspeed like 140 knots, like 250 kilometers an hour, much higher than that. So you use the rudder to control the steering of the aircraft in takeoff and in landing mainly. And then as you slow down in the landing, you have the nose wheel coming in. The takeoff is the opposite. So you have also so this is the rudder pedals here. Both sides, the rudder pedals, both in the Airbus and the Boeing move together, are interconnected in direct mechanical function in the Airbus. So both sides, the captain and the first officer, are interconnected. We have also one axis more, the lateral axis from wingtip over here to wingtip is the pitch axis of the aircraft. You use the pitch axis from the tail of the aircraft. The elevator over here, climb, descent. So you can climb the aircraft using the horizontal tail, the horizontal stabilizer in some aircraft, and also the elevator trim. So you can trim the elevator or the stabilizer, and also use the side stick in the Boeing, in the Airbus actually, the side stick back and forth. You move the elevator up and down and you climb. You take the weight up when you climb, moving the elevator up, and you take the weight down, moving the elevator down. So you descend or climb either way and balance the aircraft in the air. So it's the side stick back and forth in the Airbus aircraft. It's the yoke back and forth, the whole control column of the Boeing aircraft back and forth, profile like this. So you climb and you descend like this. The aircraft flight controls. So we have one more axis here. This is the longitudinal axis from nose to tail of every aircraft. So this you make left and right side stick in the Airbus. You move the ailerons and the spoilers, and you make left and right turns. This is the roll axis, the longitudinal axis of the aircraft. You make left and right side stick deflection, left and right in the Airbus. In the Boeing, you control aileron, spoilers, and also the flaperons here, left and right flaperon, one extra flight surface. So in the Airbus, aileron, spoilers, side stick left and right. Like this, you make a differential lift from the left and the right wing, and you make turns left and right in the air. So it's quite easy to remember. It's the control wheel left and right in the Boeing aircraft. We have the control wheel left and right turns. In the Boeing is the same, like side stick left and right. In the Airbus, also climb, descend, back and forth. Airbus, Boeing, same flight controls, no difference. Rudder pedals also, directional control, rudder and nose wheel steering. So you see, also we have the bottom surface of the wings over here. As we fly is more flat and we have the flaps extended. So we have, using the Bernoulli theory of fluid, as we accelerate for takeoff and then we fly, and also we have mainly a positive angle of attack. The airflow is moving slower below the wings, so we have higher pressure, which pressurizes the wings of the aircraft and the weight up into the air. Also you can see the top surface of the wing the surface is more curved. So using the Bernoulli theory fluid, the moving air is moving faster above the wing, so we have lower air pressure, which sucks the aircraft weight and wings up into the air. So this is the aerodynamics of the aircraft we need to know. Also the flight control system. To control the flight controls, we have one more thing for the flight controls. We have the horizontal tail stabilizer over here. I'm gonna show you how to trim. You can trim the horizontal tail of the aircraft when you fly, both in the aircraft, in the Boeing and the Airbus aircraft, also in the Embraer and the CRJ aircraft. You have the horizontal trim stabilizer. Some aircraft have switches, some others have the trim wheels. So here in the Boeing 787 we have the trim switches, normal switches and alternate switches, and the cutoff switches, or like in the more similar to the Embraer and the CRJ aircraft. So we have here, you can see here, is similar with the Embraer aircraft. The Boeing horizontal trim stabilizer switch. We have this switch to trim the horizontal tail of the aircraft when we fly. You can see it reads elevator trim switch up and down over here. So you can see elevator trim. Left click down, right click over here up. So you trim the elevator this way. You trim left click down and right click up. So right click, you trim the elevator up, you pitch the nose of the aircraft up when you fly like this, and this way you trim the nose, the elevator down, you pitch the nose down of the aircraft as you fly. This aerodynamic effect you have. So you can see elevator, what it reads here. Left click down, right click up, elevator trim. So this is the elevator trim of the aircraft, the normal channel, trimming up and trimming down. The horizontal tail of the aircraft. Here you can see the horizontal tail. We can trim when fly instead of moving the side stick up and down in the Airbus or the yoke in the Boeing. You can just trim to balance the aircraft. So you trim up and down the elevator, or you pitch the nose up or down as you fly. Also you can see the flap speed limits over here, some other information, the head-up declutter over here, now the switch, hood declutter switch, and now the autopilot disengage over here switch. We have 1, 2, 3 switches in the control wheel of the Boeing 787. So you can see both sides have the trim switch over here. Also we have the alternate, I will show you now, trim switch over here, and the cutoff switch. So we can read how many degrees we pitch up or pitch down the aircraft. Over here, nose up or nose down. Horizontal trim stabilizer here, nose up and nose down. Also rudder trim over here. We can use, we will need the flaps position, the engines information. I will talk to you now in a couple of minutes. Left and right engine, the outflow pressure, pressurizer, cabin pressurization, weight of the aircraft with the fuel on board, and the fuel temperature. So you will see also landing gear, up and down, other information will come later, auto brakes. So I'll continue here with the horizontal trim stabilizer. Over here you can trim up and down the horizontal tail. You see how many degrees you trim up and down over here in the display, in the ACAS engine control system display. Also you have, this is the normal channel, this is the alternate pitch trim over here. You can see we trim again the tail, nose up and nose down. So we trim the elevator up and down either side. We pitch the nose of the aircraft up and down. This is what happens when flying. You read the nose up or nose down. We have also the parking brakes here located next to the horizontal trim. We have the stabilizer cutoff switch over here. There's red carded switch. You can read cutoff, stabilizer, left stabilizer and right stabilizer. We open over here if we need. So this is a fly-by-wire aircraft. You can see we have the alternate and the normal pitch trim channels over here. So we trim the elevator like this in the aircraft when flying, and you can read how many degrees again you have trimmed the elevator nose up and nose down. Now it's 4.75 over here. So we have also this is a fly-by-wire aircraft. So this is a fly-by-wire aircraft. It has its own fly control computers like in the Airbus aircraft. You have the normal, the alternate and the direct control of the flight control computers, the modes of the flight control computers. So if you have failures or you disconnect the flight control computers in the Airbus, you can degrade the flight control modes and the protections you have. So you have in the Airbus aircraft 2.8 G. G is the acceleration of gravity in left and right turns, or 67 degrees in left and right turns with the side stick fully deflected in the left or the right side. Also we can climb like 30 degrees or 1.5 G's in the Airbus if we deflect the side stick full up, and then we can descend minus half G or minus 15 degrees in the Airbus aircraft. We have the protections. We need to override the flight control computers to make more like 190 degrees left and right turns. Disconnect some computers in the Airbus. Also, you can do that. You can see another aircraft is coming for line, so I'll explain you the flight control computers now. Also in the Boeing we have similar flight control computers. So you can see the Boeing 737-800 now is coming here for landing, as you can see. Here we have it. So both in the Boeing aircraft you have the flight control computers. We have also in the Airbus the alpha protection system for the angle of attack and the stall of the aircraft. I will explain you in an Airbus video what it happens. So we can see also here in the Boeing we have similar protections. We have also both in the Airbus and the Boeing we have the automatic trim of the aircraft when we fly from the flight control computers. They can estimate from the flight management computer, also the autopilot flight director system panel, the sensors of the aircraft when it flies, its attitude and what it needs to do to balance the aircraft in the air. So we have the automatic trim. We can use the manual trim all the time here from the Boeing and the Airbus aircraft. So we have the automatic trimming in the Boeing aircraft. You have a failure of the flight control computers or the hydraulic system that control the horizontal stabilizer or elevator movement. So now we have to disconnect the auto trim function of the aircraft. So we use only the manual trim switches afterwards. So you can see here we have the flight control computers, primary flight control computers in the auto position. We have also the air data computers, other function I'll talk to later, flight control surfaces in the overhead panel. So if you have a failure here of the hydraulics, you can read hydraulic system here, primary demand, left and right engine driving, on the electric C1 and C2. So we're gonna have a failure of the flight control computers, the mode will degrade. We're gonna lose the automatic trimming. Also this will affect the autopilot engagement. We may lose the autopilot function and the flight director. So we have to come down here. This is for all Boeing 737, Boeing 747, Boeing 757, Boeing 767, Boeing 777 and Boeing 787. You open from normal to cut off these switches here, as you can see. And we disconnect the horizontal stabilizer normal, and cut off, as you can see. This disconnects only the auto trim. You can disconnect either the left or the right or both of them, whatever you need to do, and then you use the alternate pitch trim for controlling the elevator trim, like this. All the time you have the alternate trim channel and also the normal trim channel, like this, and also the manual over here pitch trim channel for controlling the elevator for climb and descent. So this is the trim function, what you need to know for both, almost everything for both an Airbus and Boeing aircraft. So I'll continue now the flight controls of the aircraft, other functions, other systems. Also I will show you how to set up the flight management computer to make a flight plan for flying this aircraft. So we set up the flight management computer. We'll input all the data the aircraft needs. So I will use the takeoff gross weight, that includes the empty weight plus the passenger plus the cargo plus the fuel on board, where the fuel is stored on the left and the right wing. In the center tank we have 30% in the left and the right wing, 10% in the center tank. The flight management computer is going to calculate automatically the takeoff gross weight and the center of gravity. Also this affects the horizontal trim stabilizer for takeoff and the mean aerodynamic chord with the maximum aerodynamic lift of cruise and where the stall will begin when we fly. So also when we fly we burn fuel and we change altitude in flight. This affects the center of gravity of the aircraft. The flight management computer recalculates every second this thing until we land again. So we have this is automatic, we don't need to do anything. We only need for takeoff to set up the flight management computer center of gravity. And horizontal trim stabilizer, we're gonna use 15 degrees of flaps, 4.25 degrees of horizontal trim stabilizer. We're gonna have 23% of the aerodynamic chord position for the center of gravity and the angle of stall and where the maximum aerodynamic lift occurs. We're gonna have the runways we're gonna use for takeoff. So we're gonna use the runway 14 over here. You can see this is the runway we're gonna use for takeoff and for landing in Zurich International Airport. Let's see, it's in Switzerland. We're gonna use the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air, and the temperature of the air. We're gonna use also the runway conditions. If it decides dry or wet, we're gonna use 15 degrees of flaps, maximum takeoff thrust like 99 or 100%. And also we're gonna have 9 degrees of pitch attitude for takeoff. We're gonna take off at about 140 nautical miles per hour, 140 knots or 250 kilometers an hour. We're gonna climb through the seats. The seats are the staggered instrument departure waypoints and fixes that include horizontal and vertical navigation fixes and speed constraints for the initial climb of the aircraft and departure. I'm gonna climb to the cruise level of 25, 36, 37, 38, 39, 30,000 feet above the sea level. We're gonna cross through some waypoints, make some turns, and we're gonna initiate the descent back to the elevation of the airport like 7 or 6,000 feet above the sea level. For the stars are the standard terminal arrival waypoints and fixes that include the long final, the short final, terminal approach and landing waypoints and fixes for the aircraft. For approach, it's going to be aligned with the magnetic North Pole heading of the runway. So we're going to use again the runway 14 that has 136 degrees of magnetic North Pole heading orientation. We're going to use the heading over here in the autopilot. I will show you in a couple of minutes. We're going to set it the same heading like the runway we use for takeoff and for landing, because this will help us also to align with the Lszh localizer, the instrument landing system of the airport we use for takeoff and for landing. We need to be aligned with the horizontal localizer, vertical glide slope, the radio frequency, antennas that transmit the radio frequency we receive from the onboard antennas of the aircraft. A unique radio frequency we need to tune from the Lszh localizer over here. The radio management panel of its aircraft automatically from the flight management computer in order to follow the Lszh localizer, the horizontal localizer, vertical glide slope, at the angle of approach for landing. I'm gonna show you also that. So now I'm gonna set up. You have here the computer. I use the side stick, also the mouse pad. I'm gonna use to control. I forgot also to show you one more view of the flight controls of the aircraft over here. So you will see one more view. I'm controlling the flight controls of the aircraft of the Boeing 787 over here. So you can see I'm having also this control. You can see both the captain and the first officer. We can climb and we can descend the aircraft like this, moving together both side sticks, both actually control columns and control wheels move together in the Boeing aircraft. In the Airbus you have the side stick priority of either side or dual input, you can choose between. So we can see we have also the thrust. Over here we can control the thrust of the aircraft like this, back and forth over here. So we can actuate the thrust commanded by the engines. We have the horizontal trim stabilizer also. So hope you like how I control the flight controls here. So we can climb and we can descend, we can make turns right and left like this. As you can see, I have the side stick, the Airbus identical side stick here, horizontal trim stabilizer. So you see, back and forth. So we climb, make turns right and left. And also the outside view again, you can see the flight controls, how we climb, descend, use the rudder, left and right turns, ailerons and spoilers, left and right turns. So this is the same side stick like the Airbus. I control in the simulator of the Boeing controls using the control column over here. So we climb, we descend, make the tail up and down, move up and down like this, back and forth on the side stick. As you can see, very easy, very fast, very responsive, like in the Airbus, both the Boeing. So there's a little difference in the flight controls of the aircraft. Make turns in the air. So I'm gonna show you this, most of the flight controls of the Boeing right now. We need to know, you see both sides in the Boeing move together, are interconnected. Unless you have a failure, you need to use the override force for either side to control the flight controls. So this is for the flight controls lesson right now. I'll continue with the we'll show you here now how you use the computer to control the flight management computer over here of the aircraft. So you will see now the flight management computer over here. I have the mouse pad. I can control also here the switches and now the touch screen of the mouse pad over here. I have the keyboard function of the flight management computer you use for inputs. Over here the screen, touch screen also. So we have identity, position, performance, takeoff over here, navigation data, load air traffic control. So I'm gonna use this view over here to show you how to set up the flight management computer. So we're going in this view and we do it very fast. This time maybe less explanation, we have not much time for everything. So we go over here, we can change the view over here, what we need to see. So we have the identity of the aircraft is Boeing 787-900 GNX engines installed, and the Iraq cycle, the position. We can align the IRS system of the aircraft, Lszh, its airport, and the coordinates, longitude and latitude. So we use the route. We can use also over here the performance of the aircraft. Zero fuel weight plus fuel on board, gross weights for takeoff, reserve fuel, cruise altitude, cost index, fuel freezing temperature, and the center of gravity. So we use departure and arrival here, airport, Lszh, departure, origin and destination for the flight management computer. So we use runway 14 over here, and we use departures over here. So we can use either runway 10, 14, 16, 28, 32 for departure. So we select runway 14. We can use Zuid to Alpha over here. These seats that are in simple departure. We continue with the arrival. We can use VOM 16 2834 ILS14 ILS16 ILS28 ILS34 GLS14 localizer 28 the localizer 34. So we select ILS14 trans Amiki over here, a transition waypoint, and then this is our starter terminal arrival waypoints fixed in area 1 alpha. So we have the waypoints connected here with one line. Active route is not yet activated, is displayed with blue. So we have the first waypoint after departure. It's heading distance from the airport for the aircraft to follow. So we climb to the Zui 9 nautical miles, Zurich 701. Over here, departs for arrivals, approach and landing. So we initialize first the reserve fuel with the gross weight and the fuel on board. The cruising altitude 25,300 feet over here. The cost index 100%. Fuel freezing temperature -37 degrees. This is the flight management computer of every airplane. So we press execute. Now we have the active flight plan from takeoff displayed with purple and white. Make left turn, the heading of the runway 136 degrees, 2 nautical miles, the airspeed 250 knots, 1900, Zui 052 heading 6 nautical miles, 6000 feet. Then Nigria 071, 26 nautical miles from Zui. We fly to 7000 feet above the sea level with 300 knots. Matif descent, approach and landing here. 6 nautical miles, 6 again, Zurich 701, 6000. TRA C114, 6 nautical miles, Osnem. We make left turn here to align with the runway, 5 nautical miles, 174,000 in the runway 14, 8 nautical miles, 1,430 feet. We use flaps for takeoff, and then for landing, center of gravity trim 33%, and the takeoff speeds to this runway. V1 we rotate V2. We have departure arrivals, alternate VNAV, progress, FMC communications, hold over a waypoint, the fix, and the navigation radio. We can tune ILS localizer, VOR, and ADF. So we go back over here, the virtual cockpit over here. So we set up the lighting. We're gonna make the engine start demonstration. You can see the engines, what they display here. I will show you in a couple of minutes. You can see also the flight plan here. We have created the vertical and the horizontal. So go here in the overhead panel again one more time. So we start the APU right now very quickly. You can see the electric. We have the left and right engine driving generators, 100 200 volts, 400 Hz frequency, 120,000 kilovolts. The batteries, the primary flight control computers in the auto position. Air data computer heading flight control surfaces, battery here, towing door, FT door, towing power, window heat, the passenger oxygen over here. This is also rammer turbine on the left and right engine driving hydraulic system in the off position. When they display the primary demand, you see the fault displayed. So we turn it back on, then to the auto position, the demand in the primary. We have the electric also backup. We have the wing and engine, the ICE over here, then the ICE on or auto. We have also over here, you can see the cabin pressurization of the aircraft, auto or manual. We use the outflow valves for climb descent, pressurize the aircraft in higher altitudes, air conditioning, ventilation, oxygen of the aircraft. Flight also the recorders, cargo and APU fire over here. The flight control engines, electronic engine control for the engine with the auto start system, and the normal and alternate mode of the engines. We can dump some fuel to lose weight and make an emergency landing over here for the Boeing 787. Use left and right wing, center tanks also. The fuel booster pumps, the crossfeed valve, either left and right engine, and also the balance. We can balance using the crossfeed. So this is the fuel system, cabin pressurization, pressurizer for wing and engine at the ice, air conditioning, ventilation over here, hydraulic fluid tanks pressurization. So we need to show you now one more system before going to flight. Make the engine start demonstration. So you see here we have the systems, every system on display in a digital format: hydraulics, CPU, oxygen, liquid cooling over here, some principal system, the electric also, left and right IDG, the drive connected, the APU is running. With green we have the main battery voltage and amperage over here. You can see 31 volts, 100 to 200 volts, 400 Hz frequency. Where the hydraulic fluid goes, the hydraulic system, flaps like flight controls. We have the primary and the demand engine driving, electric C1, C2. The pressure of the hydraulic fluid 5100 psi. Also the quantity of the hydraulic, the fuel on board, left and right wing fuel tanks, center tanks. So we have 30 and 30% and 10%. 11,000, total 33,400 pounds. The land high pressure fuel valves on the left and right engine are open and feed both engines from the center or the left and right wing. The APU is fed from the left wing using the DC motor. Also we have the crossfeed valve with the net on. It can feed either engine with either pump or either tank and balance the fuel between the left and right wing. Also we have the minimum fuel temperature below which here the fuel will freeze in flight, so we need to recirculate. You see minus 37 degrees Celsius is the freezing fuel temperature. Freezing temperature right now minus 6, so it's recirculated automatically from the farex from the left and right wing into the engines to heat up the fuel in flight. Also the oil in the lubricant to avoid freezing. The pressurizer. Πάμε σε κανένα 20 λεπτό. Εντάξει, thanks. Pressurizer, oxygen, the doors are closed, the cabin can be pressurized. The gear, you can see the temperature of the brakes and the pressure of the tires. Flight controls over here make left turns in the air when we fly, left and right turns. Also the tail, climb descent, rudder, and stabilizer trim, FS display over here, maintenance and systems display, circuit breakers over here. So we have one more thing to see before make the engine start demonstration. Checklist, normal menu, before, after start, after takeoff, descent, approach and landing. Also navigation over here, communication. So we'll go back, turn off both engines over here and restart them very quickly. So turn off both engines, fuel control, fuel valves here, left and right engine, fuel valves off. So you see what happens. We have the fuel starvation, engines off. So we'll shut down the engines like this because we turn off the fuel control. So we need to restart the engines. We go over here in the overhead panel very quickly and start the auto start both left and right engine very quickly. So we have the auto start on. You will see the pressurizer from the APU is increasing, only pressurizer right now. So you can hear also the wrong roar of the engines. We have pressurizer right now, but no fuel. So we let the fuel flow on. Fuel control over here, left and right engine driving. So the auto start will kick in, will turn on above 30%, will turn on the fuel control. So we have the N2, which is the high speed starter shaft, high press compressor and turbine with the turbofan temperature engine. The N1, which is the low speed starter shaft, low press compressor and turbine with the turbofan temperature engine, exhaust gas temperature, fuel flow, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So we have the running engines right now. Both engines are running, so we can go for takeoff over here. We need to only set up the airspeed over here for takeoff and after 200. Also the heading, we're gonna use the heading of the runway for correct following of the flight modes of the autopilot. We can also use vertical speed over here, descend like this or climb. Also the altitude over here, we're gonna use So we start now. We use flaps for takeoff, speed brakes up, parking brakes off, and we increase the thrust so we can depart right now. We take the clearance from the air traffic control over here. We align, we go for takeoff. So the air traffic control, we have clearance from the tower for the runway over here. We can taxi into position for takeoff right away. So we taxi into position here for takeoff. So we use the tiller for alignment over here, as you can see. So we advance the thrust levers to full takeoff power like this, and we press the side stick and the yoke of the Boeing, the side stick and the Airbus like on 218 nautical miles per hour. We press down. So we have 87. We align with the rudder pedals. 112 V1 over here. We pitch up slightly. V1. We rotate. We have a positive rate of climb. We're climbing over here. So we climb, we initiate the departure. So positive rate, gear up. So you can see what it reads over here as we depart. Now in the displays here we have the terrain, red, green, yellow. We are 1,800 feet above the ground. 2,000, 2,000, 100, 2,000, 200, 3,000. You can see the airspeed, the altitude 4,000 feet above the sea. We climb with 5,500 feet per minute. The stall speed here when it pitches down. The aircraft a little bit when we reach the stall. We have the pitch altitude like 17 degrees. The wind direction and speed. The flight plan, we're gonna follow the terrain, green, yellow, red. Also the flight plan, and you can see also here, if we look closer, we'll see more of the terrain. So you can see the aircraft is above the terrain right now. Over here displayed with green, it's like 4,600 feet above the ground. You can see the green wave. Over here is the terrain up below the aircraft symbol, 5,000 feet right now. So we keep climbing, and now we see the outside view, and we make some turns now. Align. You can see the runway here. We just depart. So we make a turn now for alignment with the flight plan. So we keep climbing. Like this. We need to align with the flight plan as we make the turn. So you see we depart over here. We have a very beautiful view of the aircraft and the airport, and also the star sign over here. Keep climbing. So we keep climbing. You can see we have also where we are located, the Switzerland, the terrain around us, the mountains. Have to fly through the Swiss Alps. So gonna make some turns now and keep climbing. You can see we can leave the hands off from an aircraft when flying. There's no problem. It keeps flying the way it should be. It's RED. So you can see again the airspeed here. The airspeed indicated 150 knots. The stall speed amber, yellow, and red. We climb with 1,500 feet per minute. The first waypoint over here, Zui. Now we need to intercept. Gonna see it later. We have the LNAV also activated here in the autopilot panel. You see the switch on. So we have over here, keep climbing. You can see every system like in the original aircraft, also the engines indication over here. The other side, more of the flight plan, and also the autopilot panel. So we have 100% from the engines right now. This is the ground speed of the aircraft. Also, you look inside the aircraft cockpit, you see around after takeoff how it looks like. Keep climbing, make the turn now. Over here we have the Zui over here displayed. We are very close to the Zui over here. As you can see, Zui 1.9 nautical miles. So we're gonna make the turn now in a couple of seconds, align with the flight plan, and make a second turn after that to go back to the airport. As we're climbing here, you can see we are aligned now with the flight plan. We need to follow the purple line. Also here, the yellow. We need also to add more power. Really. So here we are. We're gonna make the turn now. Over here we have the Galaxy, my homeland Germany, Bayern Munich in front of you. The Switzerland here, the Swiss Alps, the lake, and the France this side. So we are almost we make the turn manually, going back to the airport. So we use right rudder pedal over here to make more faster turn. As you can see here, data of the aircraft as we turn. So this is the turn over here. We're flying Germany, Bayern Munich, and the France, the lakes also. So this is overflying Bayern Munich over here. Boeing 787 from this altitude. We need to align with the flight plan here and initiate the descent after 1 minute. So we need to align with the flight plan here with these lines. Use more right rudder, make more steep turn for faster alignment. Needs also the stall speed limit. Need to climb a little bit higher. So we keep climbing. As you can see, we are very close to the stall limit. We need to follow the flight plan over here. So we have the frozen vapors. You can see we overflying the Switzerland. We have the frozen vapors from the aircraft, from the exhaust. We can make turns. So we have the beautiful view, the galaxy over here. We need also to level off. Beautiful star sign, galactic star sign over here. And if we look around, we have the lakes behind us, the Germany and the France on this side. So we need to initiate the descent now to go back to the airport very quickly. So we use a little bit more idle thrust and flaps up for descent. Also speed brakes down. We're gonna approach and land the aircraft very quickly, as you can see. So you can see the runway we're gonna use for landing here. We have to follow over here the landing process, fly through the waypoints, as you can see, as we descend. Increase the descent rate over here and follow the waypoints one by one. The other side also. Autopilot here, yeah. So you see a nicer view of the aircraft cockpit right now over here as we are descending. Use more idle thrust over here for approach and landing. Keep descent, increase the descent rate. Also we need to start the turn now as we are descending. So this is gonna be the turn here. Also use more right rudder, as you see. Keep descending. So keep descent and also increase rate of descent here. And make a little bit left rudder right now for the turn, following with the flight line. The heading will need to be aligned over here. Keep descending. You see the runway here. Also the flight line will need to be aligned with the runway heading as we descending. You see we need to align with this angle right now as we descend for approach and landing. Make a little bit right turn, then left turn. So we are almost in alignment for the runway over here. Landing gear down in a couple of minutes, couple of seconds actually. So we use landing gear here. Also more flaps we need. Use manual approach landing now, as you're gonna see. So we need to have this view for landing over here as we're gonna land. So we have 1 more minute for approach and landing. We can see the runway. We have also the Lszh localizer here You can see the localizer we need for alignment. We need to follow the localizer approach. So we use a little bit more airspeed when we need. Increase also the angle of descent, align with the runway heading. Also we have some side wind and some wind gusts. You can see align with the center line. A little bit more engine power and decrease, align with the center line again over here, as you can see. So we have the flare of the aircraft, touchdown, very beautiful touchdown over here. Idle thrust, parking brakes, and thrust reverse, full thrust reversers over here, and we maintain the center line for slow down. So you see maintain the center line over here. A little bit left rudder. Also the thrust reverser, we need to align again. So you can see all flight controls, the rudder, and also the nose wheel and the gear behind the nose wheel all